Okay, after the investigation that you did in class, hopefully you have a little bit better of an idea of the different types of transformations that can occur to our parent functions that we talked about. So recall in the last video we talked about 4 different type of parent functions that we were going to talk about during advanced algebra. So we have linear, we have quadratic, radical, and absolute value. And those 4 functions are the 4 that we're going to focus on when we're talking about these transformations. So there are 3 different types of transformations, as you can see in your notes. We've got translations, and if you need little notes to remind yourself what these are, another word for a translation would just be a shift. So in other words, a translation is just a shift or a move left, right, up, or down. Nothing happens to it other than just shifting it one way or another. A reflection, I don't think there's really much explanation needed for that one. The only types of reflections we're going to talk about here in a minute, there's just 2 types. There are lots of other ways that things can be reflected, but we're just going to be focusing on using the X and Y axis for our lines of reflection. And then dilation, which would be a size change. And these terms may be familiar to you from algebra, or they may not. I'm going to assume by now that you're pretty familiar with those, so I'm not going to go into those too much. We're going to more focus on what happens to the function. So if there's a value added or subtracted from the x or the y, that's what's going to cause a translation or a shift. Okay, so adding or subtracting something is going to cause the shift. Now, most often we will not see anything over with our function with y. So we won't see y minus k. We'll actually see y equals, and then we'll have our function maybe with something happening inside the parentheses with the x, and then we'll have the k moved over here. Now remember, I changed it to a plus k because think about if I add k to each side, that's how I can get the same thing. So subtracting k from the left is the same as adding k to the right. This is something that we talked about, at least in my algebra class last year, a little bit. So that should be familiar to at least some of you. So when we have a function like this, it's going to be translating it. And basically shown either way, this is a translation where it's a shift, and it'll be shifted horizontally. So that would be left or right, h units, and vertically that would be up or down, k units. Okay? All right. Other things that can happen to our function would be that there's a change in sign. So sometimes we change all of the x values. So I'm going to go ahead and draw like a little line down the middle because we're going to talk about 2 different things that can happen on this one. Here, same thing, there's 2 different things that can happen. It might be shifted horizontally or vertically, or it might be shifted both. Reflection, same thing. Each one means a different thing. And so in this case, if all of the x's change, so the input into our function shape, all of those x values change, then what happens is we get a horizontal reflection, and that would mean it's over the y axis. All of the x's, think about all of the x's flip-flopping horizontally. So all of the positive x's become negative, all the negatives become positive. And then if we're changing the sign of the y, which another way to write this, if you think about maybe dividing each side by -1, because like I said, oftentimes we don't see negative y equals, we see y equals. So the way that you would actually end up seeing this function would be written as y equals negative f of x. So for example, the function, and in some this looks the same, but like if we were talking about absolute value, that would be the difference between negative absolute value of x and absolute value of negative x. This one on the right would be a horizontal reflection. This one on the left would be a vertical reflection. Okay? All right, so this one is a vertical reflection. And so then that would be over the x-axis. So all of the y's are flip-flopping up and down. And then the last thing is the size change. So we have y divided by b equals f of x, or another way to write that would be y equals b times f of x, more commonly written that way. And so what that is, I'm going to go ahead and do a dotted line again because we're going to talk about each one of these differently. That would be a vertical dilation. So a vertical dilation by factor of b. Now, if the absolute value of b is greater than 1, so if it is anything greater than 1, whether it's a positive or a negative, then it's a stretch. And if the absolute value of b is between 0 and 1, so in other words, if it's a decimal or fraction, then it's a shrink. Okay? And then over here, we've got y equals f of x divided by a. No real way to kind of simplify that. That would be a horizontal dilation. And same thing, absolute value of a greater than 1 is a stretch. So in this case, if it's divided by a value, if x is divided by a value greater than 1, so 2, 3, 4, something like that, it's a stretch. And then if it is divided by a value between 0 and 1, absolute value between 0 and 1, then it is a shrink. Now we're talking about absolute value because of the fact that we don't care if the dilation is positive or negative, because that doesn't affect the actual size change. Think about a function maybe where we're talking about y equals 2x versus y equals negative 2x, or let's say x squared. Okay, so when we're looking at these two functions here, let me make sure this is out of where my video is. There we go. If I'm talking about those two functions there, they're both stretched. They're both stretched vertically, because I could also write these as y over 2 equals x squared, or y over negative 2 equals x squared. Okay, so they're both stretched, even though one's positive and one's negative, because the absolute value of the scale factor is greater than 1. Remember, the difference in putting a negative in there is that it's one of those, it's actually going to be the difference between whether it's reflected or not. And so in this case, when we have the negative 2 in there, that's a reflection over the x-axis. So the first one here, y equals 2x squared, would just be a stretch, a vertical stretch of 2, where it would be stretched out this way. Or it would also, the second function down here with negative 2 is stretched and flipped over the x-axis as well. All right, so we've got a few examples. First thing we need to do is decide on the parent function for each. So when I look at this first one, first thing I'm going to do is get it into a y equals. So I'm just going to add 6 to each side. And that one for sure is a linear function. We just have an x to the first power in that one, and there's nothing else in there to indicate that there's a radical or a power or a absolute value or anything like that. So that's one's linear. This one has an x squared, so it's quadratic. So in my mind, I'm starting to think about what the graph might look like, because that's where we're going to go after this. Our next learning target will be about being able to graph some of these by hand. And then the last one, we've got those big, long, straight lines. So I know that that one is absolute value. So there's our parent function, and then we just need to describe the transformation on each. So our basic linear function, remember, is just y equals x. So what has happened to this basic function? So we got to look at a couple different things. So first of all, I'm going to look at this plus 6. I know that it was minus 6 over on the left, and remember that we talked about y minus k equals f of x. And so what that means is that it has a vertical translation of 6. Now, if I want to put this in more layman's terms, I would say it's moved up 6. That means the same thing, but we want to start talking in terms of vertical or horizontal, and we want to use those words translation, reflection, dilation. We're going to use those specific mathematical vocabulary words. Also, if it was going to move down, all we would say was vertical translation of negative 6. So we don't have to designate up or down. We just say vertical translation of 6, or if it was going to go down, which this one does not, we would say vertical translation of negative 6, and then we would know that would mean that it would go down. And then the negative 2x, like I said in the previous example, means two different things. So it's the negative is not applied to just the x. So in other words, it's not something like this, y equals 2 negative x plus 6, which in this case would kind of mean the same thing, and not all functions do it the same way here. But basically, because it's outside, and that would mean that it really actually applies to the y. So in other words, if we wanted to think about it without that plus 6, let's say our equation was the example from last, y equals negative 2x, we could think of it as y over negative 2 equals x. And so really that negative 2 applies to the y because it has nothing to do with the input of the function. So we're going to say it's also, all the y's are reflected up and down, which means it's reflected over the x-axis, and it's stretched vertically by 2. Okay? Next example is much simpler, much simpler. We just have one thing to take care of, that plus 10. Reminder that this could be the same as y minus 10 equals x squared. So this is just a vertical translation of 10. And so you might be thinking, what would it look like if it was a horizontal translation? So let's think about that. If it was a horizontal translation, our equation, instead of y equals x squared plus 10, would be y equals x plus 10 squared. That would be, actually, it would be not plus 10, it would be minus 10. That would give us a horizontal translation of 10. Okay, and then the last one, we've got absolute value. We've just got it divided by 4 in there. And so what I've got here is I've got a horizontal stretch by 4. Okay, so before you come to class, you got 2 examples there. I want you to go ahead and do the same directions. I want you to identify the parent function, and then I want you to describe the transformation, making sure that you're using that mathematical vocabulary.